Okay, I think we're good. How's it going?
Oh, good are you?
Yeah, I'm doing alright. We got up to 16D last time, getting through a few of those more worded style questions. How'd you end up going?
Honestly, I haven't really gotten much of a chance to look at it since then because I was out for 2 days, with a little bit of sickness.
Oh, yeah, okay, fair enough.
Yeah.
Feeling better now?
It's on and off, but it's okay. Good enough to do class and things.
Yeah, enough to still hang in there. Fair enough then. Cool. Okay, so I guess from where we left off, do you want to keep doing those kinds of questions so you can get back in the swing of it, or
Yeah,
learn?
probably a few.
Sure. Okay. So let's see, how far into this did we actually get to? I think we touched on up until at least question 2, and then I think I just sort of picked out something like this. Yeah, that's right, question 5. That was the first time we did that whole needing to do the inverse normal stuff and the z equation. Do you want to repeat any of them, or just kick off from more or less where we left off?
Just look through my cards real quick. Maybe like one or two of those inverse null ones where we get to like also like make use of a z equation.
Yeah.
And
Yeah, okay.
after that, I'm happy to do like chapter review if that's what's next.
So chapter review is almost what's next if you want to do, because
Oh,
that'll be
16 yeah, after that, yeah.
yeah. So 16E is just a little bit more on normal. It basically shows you how you can use more on how you can use binomial stuff to approximate normal. It's not really super required as far as exams are concerned because literally every time this has come up as applicable, it'll have in the subtext of the question, do not use a normal approximation to the binomial. And so it just becomes, well, okay. Um, so it might be a SAC only thing, if anything. But okay, so I guess what we'll do is we'll have a look at that. Where's that example? Yeah, here we go. They touch on it in example 8, so we can have a look at a worked solution already. So we have these metal rods that can be between a certain upper and lower bound of lengths. Anything above that would be considered, or anything outside of that range would be considered unacceptable. And we have some percentage likelihoods for those unacceptable ranges, whether they're undersized or oversized. We're told the lengths are normally distributed, and we're told to figure out the mean and standard deviation. So that's two things to find, mean and standard deviation, two unknowns, two equations. So a lot of what we got to do is try to figure out how we're going to get those two equations. Anytime you're working with normal distribution, either using the z or the inverse normal, you will end up using both. They're more or less the same thing, but you're effectively using those two tools to create your two equations. So what you start off with is creating your two probability equations. That'll be technically the fastest way to go about it, where you start with saying, okay, 5% being rejected as undersized simply means that they are less than 1.925. All right, that's what this statement here tells you. Probability of x being less than 1.925 is equal to the 5%. Same thing over here for oversized. Oversized just means it's above your range. So that gives you the two probabilities. Because those are 50-50 split and it's normal, you can just figure out the mean off rip by just doing the average of those two things. But if these are different numbers, and you can't really rely on being able to do that. So we'll go forward assuming that they're not the same, and we'll figure out how could you also get it that way. They write it using probability statements here. I would just go straight to this, to be honest, which is you have your two probability statements. What you want to do is figure out what's the z equivalent of these numbers given these probability ranges. And so x being less than 1.925 is the same as saying z is less than something. Right, we just got to figure out what that something is, and it's going to correspond to whatever this probability is. So if we do the inverse normal of 0.05, because we're doing the pointing left, using the mean and standard deviation of 0 and 1 respectively, because it is the standard normal, then that's going to get us this z value. It's left, so it's got to be the negative 1. Exact same thing for the other one. So this one's pointing right, so you'd want to use the 0.95 version. Remember, you have to always use the left pointing area, or left pointing probability. And it's going to get the positive version of that. Again, if they're equidistant, you just take the plus and minus, and then you're happy. And what you're equating it to is a z equation. So this is the x minus the mean over the standard deviation. X minus the mean over the standard deviation. Two equations, two unknowns. Solve for the one you want, or solve for the simultaneous solve. And obviously, if you already had the mean for whatever reason, you would only need one of these. Cool.
Yep.
Okay. Let's see if you can apply it. Question 5. That was the first time it came up, I believe.
Is the hold on, I was gonna say the mean is 1.96, but that doesn't feel right.
Yeah, it's slightly off.
Is it 1.55?
1.55 is the one. Yeah, that's right.
And is the standard deviation around like 0.19, 0.2-ish?
Yeah, that's right. So when you CAS solved, did you get like an and or type of option?
Yeah.
Interesting. Okay. Gave you two possibilities. That's strange. Yeah, okay.
I mean, hopefully it doesn't happen again. That's kind of weird.
Gives you two possibilities for mean and standard deviation. Yeah, okay. I guess we'll see if it happens again, but yeah, we'll move on to the next one then, part 6, and I'll do that one in the background, see if I get two options as well. Let's see, actually let me double check. Mean 48, standard deviation 15. Pass mark. Yeah, okay, these are a little bit different, but probably still worth doing just to remind yourself.
Uh, 37%.
37% is good, yep.
And 69 marks.
Yeah, that's right, 69 marks. So I have just done that in the background here. I haven't got two answers there. What was different about what yours was?
Honestly, not much. Just that, like, you know how you put the result in the front of the equal sign?
Yeah.
Mine had the fraction first and the resultant number afterwards, but that shouldn't have made a difference in my opinion.
No, it wouldn't have. Did you copy like the full number, or did you truncate it?
Truncated.
Yeah, that was probably it then. Let me see if I.
But I
How
don't know
many
why. I
decimal?
just done it again, and now it gives me one. I don't know if it's just like a bug or something. Like that's so weird. Because that shouldn't happen for a simultaneous.
No, I mean, look, there are places where you can get two solutions, two valid pairings or more. So it's not unheard of, but yeah, I think issues with truncating can happen if you don't have enough decimal places. What else? Yeah, other than that, it's going to be like domain-specific stuff for the question. Potentially only a possible domain of values are required for it. So I guess if it does happen for whatever reason, when it comes to normal, what you can then do is actually just test, hey, if I chuck in a mean standard deviation that I got, do I get 10% if I go less than 1.8? Do I get
Yeah.
15% if I get whatever it is?
Yeah.
But yeah, let's see. This one's already got mean standard deviation, so... Oh, wait, yeah, this is already finished, right? Because there's the binomial stuff that we had to re-implement. 8 looks like another one of those with the z and inverse normal. You looking to still practice those, or?
I mean, I think we're good to like move on. I don't think this one has that in part A, question 8, because it gives the mean.
Okay, so it's just standard deviation.
I guess it's just using the equation then.
Yeah, you're still using it, but only needing one of those. And you can see they've only given one probability statement there, so you don't have a second to work with. Yeah, so it's slightly easier. But anyway, there's a bunch of those there. So, normal approximation. The whole idea here is that if you do enough n for your binomial, you'll notice that your distribution, whatever it looks like, is going to appear more and more like the normal distribution. Even at low n, you can kind of still see the curve to it. depending on what the p-value is, will be where it's going to be centered. And n is just going to determine how close it's going to look like that bell curve. That's about it, really. So when do we use it? We use it when there's like a large n in a scenario. If we're told we have a large group size or a large sample size, then, or even if it's just, I think this is probably why it's not really assessed, because what someone considers as a large n is going to be different from person to person. So I would need a statement in there saying this is considered large, or they just pretty much usually just say don't bother using it. But anyway, how does a question like this get worded? Let's have a look. A sample of 1,000 people from a certain city were asked to indicate whether or not they're in favour of construction of a new freeway. 30% of the people are in favour. Find the approximate probability that between 270 and 330 are in favour. So if you have to do this binomially, you're doing a CDF, right? So you've got n is 1,000, p is 30%, upper and lower, 270 and 330. They're saying the keyword approximate probability here, and in the context of this chapter, because of what we were discussing, we now need to effectively be using the normal distribution way of calculating that rather than the binomial way. So what you do is, for normal distribution, you need a mean and a standard deviation. So we calculate that using our binomial method. So we have n and p for the mean, and then that one for the standard deviation. These are what get plugged into your normal CDF, and then that's going to give you one of these two numbers. I don't really know which one's which, they didn't really specify. You can see a slight difference because it is an approximation at the end of the day. So really the only thing that's changing here is if you're not given the mean and or standard deviation, you can calculate those using binomial parameters if the question allows you to do it, which in the exam, every scenario where it would have been applicable so far, they've said not to bother, not to do it that way. So I guess a scenario where you could be using this would be to say, hey, look, it's asking you to use a normal distribution to solve the question, but it doesn't tell you what the mean or standard deviation is. Yes, we had an example of that before, but we also had some supporting information that could be used for the inverse normal stuff. You can calculate mean and standard deviation that way if you have that information. But if you have n and p information in the question, then you can also use binomial to get those mean and standard deviation. Fair enough?
Yeah.
Cool. Yeah, a die is rolled 100 times. What is the probability that more than 10 sixes would be observed? Again, we're going to be using normal methods for solving this. Do you want to try that yourself or work through it together?
Probably like three together.
Okay. Well, what are some initial thoughts?
If you were just to like look off it as like as an you would expect 16 sixes to be rolled.
You'd expect 16 sixes, 1 out of 6 times 100. Yeah, okay. Fair enough. So that will be like your E of X, basically. NP.
Yeah.
Cool. What else?
N is 100.
N is 100. Yep.
I mean, using that, we can calculate the other things as well. The variance and standard deviation.
Correct. Yeah. So we'll go standard
I can do
deviation,
that.
square root. Yeah, if you just want to punch that in the calculator.
So variance is going to be 13.89.
Okay.
And then Uh, standard deviation is going to be 3.73.
Yep, those are good. Got a lot of cool information there.
I'm not too sure after this. I wanted to say Bernoulli sequence, but it's more than 10 sixes.
Yeah, so like if it didn't if it didn't have this statement, all of these are Bernoulli sequences. Like all these could be a CDF. There's no reason not to use a CDF. And I think that's the main problem. That's one of the main problems anyway with using normal approximation. We have a CAS. Like there's no reason not to CDF this using Bernoulli sequence. You got N, you got P, based on the 1/6. More than 10 sixes would just be 11 to 100 as a CDF. That would be super easy to do binomial way. The challenge they're posing here is to use a normal approximation to it for some reason. I guess purely just for a deeper understanding as to how the probabilities relate to each other. So if we think about how we would do this using a normal distribution, probability of more than 10 sixes, how do we do, like ignoring everything else, it's just x greater than 10 effectively. How do we do that using normal? So in other words, if I hide everything else and I just said solve PR x greater than 10 using normal, could you do it? And if so, what information, or if not, what information are we lacking?
I don't think you can do that.
Okay, why not?
The Some of the information.
What's stopping us from solving it just by looking at the probability statement? What's missing that we would want to do solving it with a normal method?
Um, you need the Z variables.
You could convert this to a Z. How would you do? How would you convert it to a Z?
Using mean, standard deviation, and
Yep,
variance.
that's it. Using the Z equation with the x mean and standard deviation. So we have the x, we have the 10 there. And so what that ends up meaning is we're actually missing the mean and standard deviation. What could we do to get them?
We already got him.
We got them. Yeah, precisely. So whenever we're doing anything normal related, we need mean and standard deviation for calculating those probabilities. Anytime you want to calculate a normal probability, it is the normal CDF, unless of course it's tech-free, in which case using those approximations with the bell curve, the whole 68, 95, 99 rule stuff. But probabilities using normal distribution are always done by a CDF. And so all we need to do is plug in everything that should make sense now. So more than 10 sixes for normal, more than is always the same as more than or equal to. Upper bound is definitely 100 now because we're doing it only 100 times. The mean is, we had that as 50/3. Standard deviation is about 3.73. Now obviously you'd use the actual figure, but for our purposes here, we're just going to plug it in. And yeah, that'll give you a roughly 96% likelihood outcome, which should make sense given that we know roughly 16 times is what we should roll over 100. So more than 10 sixes should be fairly achievable, which it turns out it is. Fair enough.
Yep.
You could do it with Z. So once you have your mean and standard deviation calculated via binomial, you could convert your x to a z and then do the CDF with a mean of 0 and a standard deviation of 1, but using the z stuff now. But that would require you to convert the n of 100 into a z and the 10 into a z, which obviously is just more work for no real reason, but theoretically possible. Fair enough on the procedure?
Yeah.
Cool. Let's see if we can apply it to question 2 now. 50% of the voting population is in favour of candidate A. What is the approximate probability that more than 156, sample of 300, will be in favour? Basically the same question.
Yeah. No biggie. Um, 24%.
24% is correct. Yeah. I'm pretty sure this is all they're going to be. Let me
So
see.
it's just normal CDFs.
Yeah, just normal CDFs, precisely. But the change here is now we're not given the mean and standard deviation. We have to calculate them via binomial.
Okay.
NP, approximate probability. This one's slightly different
Okay.
because you're given. Well, if you're going to try it, maybe I won't say too much. Question 4 looks to be worded a bit differently.
Put A 25%.
25 seems a little bit low. Let's see. What do you have as the mean and standard deviation?
Mean of 16.
Yeah.
And standard deviation of 15.36.
15.36 is large there. Square root NP1 minus P, or just square root and...
Ooh, square root it. My bad.
Oh, you had variance. Yeah, okay.
Okay, makes sense.
Yep.
Let me fix that up real quick.
All good.
78%.
Yeah, that's a lot better. Nice. And then part B is whatever. The main trick there was getting your head around the fact that you were given the mean, basically.
Yeah, I'll do part B anyway. It's just changing the bounds.
Yeah, it's just changing the bounds, correct.
1%.
Yeah. Yeah, about 1%. Let's see, is 5 any different? P. Okay. Sure. It's very similar in the sense that, like, cool, I'm not going to tell you outright what it is. I'm going to make you do a slight calculation rather than just tell you the number.
Yeah.
Yeah, if you want
Remember,
to. Hey,
there's some exam questions. Like, remember we were doing like 3, 4 exams.
yeah.
Some of those probability questions because I never really attempted those. Let's
Yeah,
see.
so the reason why we haven't done those is because the 3, 4 exam questions, what they do is they step through all the probability types, and they do it in a full sequence.
Oh,
So
okay.
you might
Yeah.
get some normal to start with, then it becomes binomial, and then they chuck in some sampling and estimation. So they kind of, from question to question, change it up on you.
Yeah. So we have to go through the whole thing till we do that.
Yeah, I mean, I guess it depends how familiar are you with the sampling and estimation stuff. Because if you're fair enough with this, which, to be honest, sampling and estimation, just binomial. There's two things you got to remember for sampling and estimation to convert it back to binomial, and then you're fine. Um, we can go through the whole thing though. That's fine. I mean, you're gonna have plenty of time to go through exams.
Okay. Then I guess we'll just do chapter review 16.
Oh, you want to do the 16 chapter review? Cool.
Yeah.
Yes, that'll be specifically all the normal stuff. So you're either doing CDFs for finding probabilities, or you're doing inverse normal slash the Z formula for basically everything else. Um, Tech free or tech active? Where do you want to start?
I guess we'll just do a bit of both.
Yeah, we can do a bit of both. Sure. Um, yeah, we'll go through as many as you can be bothered with until you're confident with them. Question one.
Negative P.
Negative P, as in for this.
Yeah, 1A.
Not negative P, because that would might. So let's say P is 30%. Negative P would be negative 30%. So not quite great. I get what you mean by doing a little flip, but you've just done a flip a little bit off. A negative sign does go on the P, but something else has also got to be in there.
Not really sure how it goes after negative P.
Okay. I'm going to draw a hypothetical. So let's say what variable did they use? They used A. Whoop, almost crashed that. So let's say this is my A, and just hypothetically speaking, it's located there. Let's say 20% is to the right of A there, which would be the Z greater than A sort of thing. Then it follows that the other side must be 0.8, right? Roughly speaking, if 20% is over here, 80% is over here. I've got my letters back to front here. So the one we were given was Z less than or equal to. So this one's the P. So if P is approximately 0.8 in this hypothetical, well, negative P would be negative 0.8, which is not great. What can we do to convert from 0.8 to 0.2? So
Um, 1 minus p.
1 minus p. There you go. So not just negative p, because that will make it a negative number. You got to start with total and then subtract the bit you've already got to get the bit that you need. Yeah. Cool. Okay. Bit more challenging now. Z less than negative a.
So negative a. Let me move your little curve again.
Wait, did you say for me to draw it, or are you gonna draw it
No,
yourself?
I'm just gonna look at the I'm looking at the curve that you already drew.
Yeah. Yeah. Okay.
Is this also p?
Uh,
Actually, no, it's not p. My bad.
not
Um,
p. You're right. Yeah.
I was gonna say it's 1 minus p again.
What stopped you?
Uh, self-doubt.
Left out. Okay. Sure. Yeah. You're right. 1 minus p is correct there. So if I briefly redraw it this time, instead of having a over that side, you now have negative a. Because remember, 0 is in the center.
Yeah. Also, I mean, just sign analysis from the last question. You put a negative on the a, so you probably just want to flip the if you flip the inequality, it'll be the same thing.
The negative on the a, flip the inequality. Yeah. Yeah, that works with the standard normal because it's symmetrical either side. Yeah, basically what was going to happen. Nice. And part C, again, slightly different. It's going to require another sort of set of symmetries.
Yeah. Um, 2 minus 2p.
2 minus 2p is a little bit off. I like that you got a 2p in there though. That's good. One of the things I think you might have done would have been to just add the two together. Just remember they have some overlap. So figure out where they overlap and where they don't. What bits you want to keep and what bits you don't want to keep.
Minus 1 minus 2p.
-1 is good. The 2p needs to be positive though. Let's see if you can have another crack at that. Why that becomes positive.
Oh yeah, because you put the negative sign on the bracket and then 2p should be positive.
Okay, cool. Yeah, I
You
mean I
keep
haven't
them
actually done the
both.
arithmetic. Yeah, I was hoping you'd see it. Cool. Awesome. So yeah, 2p -1. Final answer for that one. Yeah. Okay, question 2. Normal with mean of 4, standard deviation of 1. Z is standard. If X is that, then Z is that. What's the A under this circumstance? They're starting out with relatively harder questions.
Okay. Let's see. Minus Is A -1?
A is -1, precisely. Yeah. So the hack for that one, if you weren't already doing it, was rather than going through the whole Z equation, you could even just think in terms of like, okay, Z is basically number of standard deviations. So being less than 3, one right of 4, oh, one left of, yeah, one left of 4 is 3, standard deviation is 1. That would therefore mean it's one standard deviation left, so -1. That's another chain of logic you can follow, but the safest by far is just plug everything into the equation and let it solve itself. You'll see for yourself which one's easier
Yeah.
for you.
I did normal CDF
Oh,
and then for -infinity to 3 for the like x variable,
oh no.
and then I use that number and put it into inverse normal for
Uh-huh.
the standard normal for Z, and then I got -0.99, like many nines.
How very tech-free of you.
Oh, my bad. I forgot about that.
Oh, good. Yeah, yeah. So the options you have here then. Well, maybe now that you remember it's tech-free, do you want to try it again tech-free or?
No, I kind of get the gist of it. It's just this
Yeah.
kind of standard deviations.
Okay. Okay. Well, I mean, these are the same thing then. So if you want, you can skip those and go on to 3 if you're happy enough with that. Mean 8, standard deviation 3. Oh, transformation. I mean, we can do it, but it'll be a sack rather than an exam type thing. What do you think?
Can we just like go through how it looks? I'm not really sure what to do, but
Yeah, okay. So mapping the normal to the standard normal is going to be a matter of remembering what the normal distribution equation actually is, or at the very least knowing where the terms should be. So let me see if I can do this from memory, actually. I think it's 1 over standard deviation root 2 pi e minus half x take mean over standard deviation squared. I believe it's that.
yeah, that's what I've got it on my book.
Nice, nice. And so you don't really need to know all of that. You really just need to know where are these things and where's that. Because once you know, oh, it's a dilate factor from the y, it's a dilate factor, it's the inverse of a dilate factor from the x here, since it's 1 over, and it's a translate factor for the mean. So as long as you can know those things, you'll be fine enough for this question. We're told the normal has a mean of 8, standard deviation of 3. So in other words, there is an 8 there and 3 is there. How do we transform this normal distribution to now look like the standard normal? So in other words, what kinds of transformations are we going to apply to this equation to make it now look like 1 over root 2 pi e minus half x squared? Because that will give it a mean of 0 and a standard deviation of 1.
Okay.
That's the gist of it. Do you want to take it from there, or shall we continue like this?
Dilate factor 3 from x-axis.
3 from x, yes. That's what it currently is. So if you want to get that disappeared, we got to flip it.
Dilate by 3 from the y-axis.
Oh, yes, sorry, you're right. I actually got that wrong. Dilate 3 from the x. This is from the x. So yeah, you did have that right because you put a 3 up here.
Yeah, cool.
My bad.
Then dilate by factor 3 from the y-axis.
3 from y. So that would need to change then, because 3 from y would mean putting a 3 here again. Because you remember how transformations look. You've got y equals a f of x for your dilate factor from x, but you've got y equals f of x over a for your dilate factor from y. So whatever number you say goes in that spot or that spot, depending on which one you're doing. So that would therefore have to be the third instead. So that would be dilate third from y. From the y, because it's going along the x. Yeah, okay. And that's just because of where they end up being when you do the whole x dash y dash rearranging stuff.
But, just say so when you apply that 1/3 to where the brackets are,
Mhm.
wouldn't that become 1/9?
You replace the standard deviation. Oh, hang on. You replace the denominator with whatever your dilate factor is. So if it's x over a, then every x gets replaced with x over whatever the number is. So if we did what you did, it would be x over 3 minus mean over the standard deviation. And then you're simplifying that because you're replacing every x with x over that number. Whereas if you did a third, you're now doing x over a third divided by 3 minus mean and simplifying that one. That then's going to become, so x over third is just 3x, and you've got the minus mean over 3, and then those are going to end up cancelling. Make enough sense? Oh, dropped out. Welcome back. I'm assuming you dropped out like at the start of that explanation.
Yeah, when you're just about to say what would happen if you f of x on a.
Yeah. So wherever the a is whatever dilate factor you're introducing. So if you wanted to introduce a dilate factor of 3 from the y, it would go in the denominator spot of the x. So that would be essentially doing this option here. We have x over 3 minus mean over 3. And that's going to simplify to combine the 9, which we don't want. Whereas if we choose dilate factor of a third, we're putting a third in that spot, which, well, x over a third becomes 3x, and then you'll see the 3's will cancel down.
Yeah.
So that's the difference there. They didn't even bother putting it in words, actually. They just did x dash y dash stuff. So it's, yeah.
I guess the last translation is 8 in the positive horizontal direction.
Yeah, where are we at? So it's already 8 in the positive horizontal. Remember, we're trying to get back to
Or 8 in the
nothing.
negative
So yeah, it would be 8 in the
horizontal.
negative direction. Yeah. Yeah. Let me just triple check that right now. So in the answers, they had x dash is x minus 8 on 3, and they had y dash is equal to 3y. Those are the transformations that are given. So when you flip things around, that's going to be 3x dash, yeah, 3x dash plus 8 is equal to x, and y dash on 3 is equal to y. What? Why does that look like they're going from standard to normal? Did I just misread the question? Give the rule that maps x to the standard normal. Going from x to standard normal. Dash equals x minus 8 over 3. And y dash is 3y. You would then rearrange and plug those in. Oh, yes, because you then end up with y over 3 is equal to 1 over 3 root 2 pi. E minus half. So it was x is getting now replaced with 3x plus 8. Whoops. And there was the minus 8 over 3. Those are going to now cancel down. Y equals 1 over root 2 pi. E minus half. Minus 8 plus 8 cancel. And 3x and x. Well, yeah. Cool, so that was right. As far as what we would have had to have said then, dilate factor I did have these backwards then. Because if we have it this way, dilate factor of 3 from x means x goes to 3x. And then 3x, well, actually that's just it. So these are back to front. Those are back to front because I forgot the flip. Is that it? Dilate 3 from x should mean putting a 3 there. Dilate third from y should mean putting a third there. What have I done? Dilate 3 from x should mean y equals 3f of x. It's going away from the x, which means going in the y direction. Dilate third from y should then look like that. And then the translate, which we're going to say y equals 3f 3x plus 8 because it was a shift left by 8. So I think I'm just losing it. These are fine. I'm just forgetting how they relate to the x dash y dash stuff. Yeah, I'm just having a moment. Good thing it's not accessible, or not being assessed, eh?
Yeah.
Anyway, that's something I should now revise. My transformation stuff. Uh-oh. Anyway, x is normal random, mean and standard deviation unknown, except for the fact that they're related in some way. Okay.
Kind of hard.
Mean less than a less than b. Probability of x less than b is p. X less than... Jesus.
Dude.
Alright. I mean, I have an initial idea of how I'm always going to start these kinds of questions. I'm curious if your idea is the same.
Is 4A mean on P?
Oh, jeez, maybe. Let's have a look. 4a. Mean on p is pretty much right. It's divided by p. You're not going to put the mean there, though. Because x less than b, that's good. That's the p there. Unless, did you misread this as the mean?
Oh, oopsie daisies.
Yeah, okay. Yeah, so that's just q on p. So if that's
Wait,
what you
wait,
meant to
wait.
do, then yeah.
Isn't it the intersection that goes in the numerator.
Yeah, which is why you probably have to think about it a bit harder. But x less than a intersection x less than b, this is where you'd want to have a picture. So you wouldn't actually know what does all this look like, and then what you would end up seeing
Okay.
is because a is less than b,
Yeah.
the inequalities condense into each other.
Yeah, got you. So
And
like basically where I saw mean on the first sentence, that could have been like the first like inequality. I could have put a Q instead of mean.
yeah, I mean, I think that was sort of just a very quick fire answer, which would have probably wanted or appreciated a bit more detail in the picture and stuff. But if you can see where all the things go, the fact that these inequalities condense into each other, the fact that's a P and that's a Q, those are the main things to make sure you get right. Whether you do it in a picture or with your head is up to you. But yes, based on what you said, ultimately, if you didn't put the mean there but put a Q there, it would have been correct.
My bad.
No, you're good.
Q mean minus A.
I can't tell if the answer in the book has gone needlessly overcomplicated or if it is a tough question. I guess we'll find out.
No, I'm honestly not too sure about this question.
Yeah, okay. So let's start with a bit of a picture. So let's get the key information that we have currently. Let's see what kind of symmetries we can use. Okay, null random variable. That's about it. Cool. So mean is dead center. Let's try to make that a bit better. Mean is dead center. It's less than A and less than B. So we got an A over here. We got a B over here. X less than B is P. So from here onward is P. X less than A is Q. So from here, it is less than here. Yeah, both are less thans. It's Q. Find probability of X being less than 2 times the mean minus A. Putting 2 times the mean minus A on the graph is going to be a challenge.
Because we don't really know exactly what mean is. It could literally be like at
Yeah.
the very far left of the graph.
Well, I mean, it's the mean is always going to be the dead center. It's
Oh,
it's the A and the B that could be literally anything, as long
one
as one's
minus
less than the
A.
other.
So
Let's
it's
see.
okay.
So 2 times the mean minus A. Is that always within a certain bound? Double the mean. So if these are really, really close, like let's say this is 10, this is 11 and 12. 20 minus, it's going to put it all over there. Versus if these are super large. So 2 times the mean minus A could be anywhere in there, unfortunately. Okay. What do? Well, what we'd probably want to try and do is get the mean in terms of A. So instead of having a U, the mean symbol there, replace it with an A in some way, shape, or form. I don't know if we're going to be able to do that. Like one of the things I'm thinking of is you got the symmetry. So you've got, oh wait, hang on. Yeah, we're getting all right. So we could do, if that's A, mean minus A gives you the gap between them. So this distance here is, sorry, A minus mean, other way around. A minus mean is that. So if we do the same thing this way, this is also a gap of A minus mean. Mean minus that is going to give us, so
And there's just gonna be 2 mean minus A again.
yeah, there you go. Is that what we wanted? Yeah, it
Yeah.
is.
What it asks for, I think.
Yeah, because mean minus A minus... Oh, hang on. Oh yeah, because minus minus, so plus, yeah. 2 mean minus A, so that is that spot. It's kind of cool. And then from there, x less than that, we want all of this. Whereas what we can do instead is just say, okay, well, if the positive version of this is q, sorry, if going left from here is q, and then going right from here is also q, so left from here is going to be 1 minus q. Let me see if I got that. Oh my god, I did. Weird. That's kind of fun. Yeah, so I was looking at this sort of overlap situation and I'm like, there's not a whole lot we can do with the way things are with these inequalities right now. I was thinking maybe you could do something in here, but we didn't want b's in it. What we had was 2 mean minus a, and I'm like, okay. I thought initially that could go anywhere on the graph. Apparently it can only go here, as we found out just now. And so my assumption was, cool, let's see if we can do something to get rid of the mean. How can we do that? Possibly with symmetries. First, figure out what we have initially in terms of A. Well, we have this gap, right? We got the A minus mean, which is the distance between those two things. Symmetrically speaking, on the other side must also be a gap of A minus mean, since they have to be equally separated about the mean, whatever the mean is. That gets us the figure we wanted, which kind of just happened by circumstance, to be perfectly honest. And then once we had that, well, the rest just became symmetries. So this was the symmetry of that, so we use that thing's information and then flip things around until we get the one that we wanted. Okay?
Yeah.
That was a fun one. My god. Challenge.
I guess I need to really work on my tech-free skills for this section.
Yeah, I mean, even like that was also newish to me as well. So you haven't actually done these questions before, like to this extent. So don't worry too much about having not got it off rip. But yeah, definitely doing. I mean, you said yourself you haven't had too much time to do much of this chapter at all. I think you did what, A and B and a little bit of C, if I remember.
Yeah.
Yeah. So you haven't done a whole lot of this as is, and we're going straight into chapter review. Should be just a bit of motivation to practice a bit more.
Yeah. Cool.
Easy. But yeah,
Thank you very much.
wherever you're up to, I'll kick back off. Even if you want to go back a chapter, like more than fine, do it.
Cool. Thank you.
Take care.